Hello everyone, let me welcome to you the video solutions of the question that we are about to solve. Okay, so the first question is problem 1, the operations on even number. Okay, difficulty level easy. Problem statement: write a Python program using the NumPy library to create an array of even numbers within a user specified range. The program should take two integers start and end as input. Okay, like we have to take two integers as a start or end, generate all even numbers in that range. So you have to generate every even number that is in that range. Find and display the sum, product, minimum and maximum of all elements. Okay, like the elements that are present in that range, you have to find sum, product, minimum and maximum of elements. Input format. So the first line contains an integer start, like the integer that we want to start from, the starting value of the range. The second line contains an integer and the ending value of the range. Okay, output format should be display the generated value, number array, sum of all elements, product of all elements, minimum and maximum values in the array. Okay, so here are some constraints. Okay, and here are the sample cases. If we take 2 and 20 as a starting and ending, so it should be saying that array is equal to 2 4 6 7 to 20, and its sum turns out to be this much. All right, and product turns out to be this much. The minimum is 2 and the maximum is 2. All right, and one other sample input is like 5 and 15. See, it's odd and odd, so we will take 6 and 14 as starting and ending point, because we are only going to consider the even values. So sum is 40, the product is 8640. Okay, minimum 6, maximum 14. So we have some test cases. We will try it when we will be discussing our code, right? So just to minimize our time, I have already written the code, so I'm going to explain you what we have done. All right, first of all, we have imported our library as np. We are making it as alias. Okay, we are importing our library numpy as np. First of all, we are taking the inputs from the user. First of all, we are saying start. We want an integer input, that's why int input, and as like input, we want an integer. Okay, then we are creating a variable name even. Okay, then we are calling a range function just to make our array that we want, that generate array of even number in that range. Okay, first of all, we are considering start can be even or odd. The user can give you even or odd, both values, right? Then we will just make the only even number, we will do this. If start is even, this will result into 0. This thing will result into 0. We use modulus and it gives us the remainder of the division rate tool. Okay, it will give 0, otherwise it will return 1. If it will return 1, it will be like the even number we are looking for. If it's 3, it will become 4, right? If it's like 5, if it's 4, it will be 4, right? And the n plus 1, because we want to include the last value too, and we are stepping with the two values. Okay, then checking if array is empty, right? We're checking that if array is empty or not. So we're just simply doing the we're putting if and asking if the size we are using the size function here. Alright, events dot size is equal to 0. We can use size to determine what's the size of array, right? Then if it's 0, it will print no even number found in the given range. This means that we didn't found any even number in the given range. Else it will print array and the events. Alright, it will print array and the events. So in the else statement, we are continuing using the numpy functions only. Total sum is equal to np.sum events. Here the values that we have taken and then arranged. Okay, we're just getting the all array, making it array over here, and now that array is getting summed, okay, by using the sum function of numpy library. Then total product, we are going to make the total, we are going to have the total product by using the prod. Okay, we are using the prod function from numpy library. Okay, we are getting the product of every number that is existing in that array. Then again, every number that is existing in that array, we are having min. And again, for the max value that we want to find it, for minimum we are using min, for maximum value that we want to find, we are using max function of the events, right? Then we are printing it, the sum, the total sum, the variable that we have created for the sum, product, the total product variable that we have created for the getting product of the all numbers in that array, and the minimum. For minimum we are using min, and the maximum we are using max. So let's try our input, right? Let's go. Highlight now. See, over here you got array, like it was 15, we added 1 over here, 16, 18 and 20. Sum is this and product is this. Minimum is 16, maximum is 20. Now moving on with the next example. Next text case, my bad. Okay. Again, we are getting 6, 8, 10, 12, 14, 16, 18, 20. Sum is this, product is this, minimum 6, maximum 20. Okay. Now the last test case, we have to try this one. No even number found in the given range, as we have said in the if condition, right? If size is equal to 0, no even number found in the given range. Now moving on to the question number 2. Question number 2, exam score analysis using NumPy. Okay, difficulty level easy. Let's read the problem statement. The exam scores of 10 students are given. Means we are given with the 10 score that student have achieved. Write a Python program using NumPy. First, to display the array of score, we have to display the scores. Find the mean and median of the score. We have to find the mean and median, obviously, and display all the scores above the mean. Like if any number we got is above the mean, we have to display it. Count how many students scored below the mean. We have to count the number of students that have scored below the mean, right? Input format, like we have to put 10 dozen integers separated by spaces representing this exam scores. Output format, display scores array, mean and median, scores above the mean, count of scores below the mean. Okay, that's how we're getting the output. Constraint, that each number should be between 0 to 100. Each score should be between 0 to 100. We are using NumPy for all calculations. Some sample cases 56 So this output comes out to be like score as an array of the numbers. Okay, the mean, we are getting the mean of it, the median of it, the like score above the mean, like 77 is above the mean. So first of all, we're just like counting the numbers that are above 77. This one, this one, this one, this one, this one, and this one. So here it is, and it is in an array which is meant to which is array of the number which are above the mean. Okay, so we have to count like how many numbers are below the mean. So we will count it. We will use NumPy how to do it. Then again we have an example. Again the same goes like this. So here let's proceed with our code, just for making time a little bit shorter. I have already written the code. So here we are importing NumPy as NP as we did before. Scores, we are creating a variable score, and then we are creating we are calling NumPy, and we are creating an array, and we are making it firstly we are making a list, then converting it into array. We are taking input integer, and then we are splitting it because we also have space there. So we are splitting it just to get the and we are using maps, so that every input that we are receiving is an integer, and we are splitting it and making it into firstly in string, and then we are converting it into array. So then we are printing the scores, saying score this. Okay, then we are printing the scores by using it from here. Then we are taking the mean median using numpy. So mean value is equal to numpy dot mean. Over here we are using the mean function to get the mean of the score, the values that we are having in the scores. Getting the mean of it, we are using the mean function. Then we are for the median value. Okay, again calling numpy library. From there we are calling median function, and we're giving it value of the value that we have already stored in score, right? Then we are again printing mean value, printing median value. So for scores above mean, we are creating a function like above mean score, and then we are taking values from score that we had the array over here. In that array, we are putting a condition that if score is greater than, we are creating an array from the past array, putting condition that if scores are greater than mean value, then only this above mean will be storing the values of scores, naming it as above mean. Otherwise, they will be ignored. Then we are printing it. Right, that to count the scores below the mean, like how many people scored below the means. First of all we are creating a function, we're creating a variable, and then we are calling the sum function. Here's the catch, like here's, you have to be careful. First of all, we are doing the sum of. Here we are creating a boolean expression. There scores which are less than mean value, they will generate either 0 or 1. Here you will get, it will run for every, it will check every value that is given over here in our input. It will check if scores is less than mean value or not. If it's less than mean value, it will give 1. If it's not, it will give 0. And again then we will do the sum of it. We'll do 0. If there's a 0, we definitely 0, adding 0 to something won't give you any result, so we will only add the 1 and we will get the count of it. Again we are printing it. Let's try to do with the give it test bit. Let's try to verify it. Alright, so here we have scores, just like the way we gave it. Okay, the median is this, mean is this, median is this. They both are same. Scores above the mean like this, 95, 90, 80, 85, 80, 75. See, not including this one, like 1, 2, 3, 4, 5. See, number of score below mean is 5. Right, now going with the other test case. See, scores are 100, 50, 75, just like the way we gave it. Okay, then we are getting the mean of it, the median of it. The scores above mean is this, the scores below mean is this. Alright, that's it. Now moving on to the next question. Question number 3. See, it is similar as we wanted, right? So moving on to the problem 3. Matrix, reshape, flatten and stack. So the question asks us, problem statement is, you are given a 1D numpy array containing numbers from the start to end, both inclusive. We have to include it. Alright, reshape the array into a matrix of R row and C columns using specified. Flatten the matrix into a 1D array. Create another matrix of the same shape containing numbers from another range, start 2 to end 2. Start 2, like first of all we create start 1, then we start, then we will create start 2, we will be taking values for two matrices, so we have to take the starting and ending values for them so that we can create values and arrange them. And then we have to stack the two matrices vertically and display all the arrays after each operation that we are performing. Input format, 4 integers separated by spaces, start and start to end to, right? We want 4 like 4 input, right? So like that we are going like with the like we are going to take it with the spaces. We are taking the input with some spaces, and then the second input we want to take is RC, right? Rows and column of the reshaping. The reshaping we want to do to our matrix. So output format should be display the reshaped first matrix, flattened first array, second matrix, stacked matrix. Okay, some constraint. And then here are some sample cases. First of all, we are given 1 and 12 as starting and ending point, so we got a matrix from 1 to right from 1 to 12, and again 30 to 24. Again we first of all we flattened it, and we mentioned about the second matrix, right? It started from 13 and ended on 24. Then we stacked the matrix like this, vertically stacked, just like you eat a cookie, cream cookie. It is stacked one upon another, right? Something like that. Then we have some test cases. Now let's move on to our code, and I have already written the code just to save our time. Let's go through it. Okay, first of all we are importing numpy as np. First of all, calling the library numpy as np aliases, using aliases. So first variable is start, the second is end, second is start to, and and last one is end to. So we will be like getting the input from user, that would be comma separated, but we will put values in it using map int input and splitting the value that we will be getting, right? Then again for rows and columns, we are following the same pattern, just like the way we get the values one for each other in this via this format, right? We have to create the first array. To create the first array, we are just naming it r1 and np dot arrange. We are arranging the numbers from start and to the end plus 1, because we want that to be included too. So we're arranging it, so we will get from the starting to the end, that what we want. Reshape into matrix. So to convert this that we have 1D array, right? We want to make it into matrix. So we'll doing it matrix 1 array dot reshape. We are using reshape function to reshape our 1D into into the column, rows and columns, into the matrix that the way user wants. Okay, so we will print the reshape matrix in the way the user asked. Then we are flattening the array, the matrix that we have made already. We are just flattening it. Have we done it? Like, yeah, we had it like this. We then just flattening it. So for that we are using the flatten function like this. We are just saying that we have to use the, I think it's called attribute. We are using the flatten attribute from numpy library to flatten this our matrix. Then again we are printing it. Then again we are arranging our array 2 like this. We give the starting point and the ending point plus 1, because we want both to be included. Then matrix 2, we are again reshaping it the way the user want, like same type of rows and columns they want, right? Then we are printing the second matrix, right? Then we are stacking it. We are putting like the cookie and cream thing, the thing I have told you, like stacking it one upon another. So for that thing we will use like VStack. VStack is a function that stacks two matrices. Okay, so again we are printing that. So our input is this. Let's put it and find out. So here's the received matrix, right? Then we got the flattened one, the 2D is got into 1D, like the second matrix. We generated the second matrix, then we stack the second matrix we stack first matrix onto the second matrix. You can see we got a bigger matrix. Now let's verify the second test case. Okay, so again here we reshaped. It couldn't compile. Okay, reshape matrix. See, 1 4 we wanted it, right? 1 2 3 4, like the way we wanted it in a 1D, right? So we got the 1D, and then we are flattening it. Again, it's a 1D. You're flattening it. Again, you will be getting the same matrix that you want. The second matrix we want, we got 5 6 7 8, right? Then again for second matrix, no, for second onto the top, first stack matrix, we are having the first matrix on the top of second matrix. So here it's verified for generating from 0 to 4, right? We did the code over there. We have, like, if we check it, like for that thing we have created an array over here. We have created an array with arrange function, giving it starting and ending point. This function will create the numbers with the limits that we want. We want it like from starting to ending. We will do it without any loop. This thing generates number without any loop. So yeah, without using any loop, we create the numbers. We generate the numbers with the help of this thing, and it goes linearly. So that's all for today's solutions. Thank you for being with us. See you another day. Bye.